This is the ninth episode of our Chinmaya Algebra series. We're given that p squared minus 15 over p equals 4, where p is not equal to 3. And we're looking for the product of p plus 1, p plus 2, and p plus 3. Note that we are given that p is not equal to 3. We have to at least think about why it's not, or why p should not be equal to 3. And if we check, by substituting p equals 3, we get that 3 squared minus 15 over 3 is equal to 9 over 5 is equal to 4. Therefore, p is a root of the given equation. Saying that p is not equal to 3 is saying us or telling us that the other roots of the equation must be what should be used to evaluate the given expression. And that's the track that we will pursue for the solution. So we'll try to rewrite the given equation as a cubic equation by multiplying both sides by p. We get p cubed minus 15 is equal to 4p. Rearrange to get p cubed minus 4p minus 15 equals 0. Now we know that p equals 3 is a root of this equation, so it can definitely be factored out from this equation. So we get p minus 3 is equal to something. And that something must be quadratic because we have a cubic equation, we factored out a linear expression. So this must be p squared plus something plus something. The easiest to figure out is the last term. The constant here should be positive 5 because the constant in the cubic equation is negative 15 and one of the factors already has minus 3. So this one must be positive 5. Now what's left for us to figure out is the middle term. Of course, it must be something that has a p on it. The easiest way for me to find the coefficient of p in this quadratic factor is to realize that if we expand this product of a binomial and a trinomial, the only terms that will contribute to a p squared are the negative 3 times p squared and whatever the coefficient of this p and the 1 here. So let's call this, let's say, x. So that's x p squared must be equal to, comparing it to the original equation, it has no x squared, so it must be 0. Sorry, it has no p squared. It must be 0 p squared. From here, we get negative 3 plus x is equal to 0, or x is equal to positive 3. Therefore, the factored form of the equation we want is p minus 3 times p squared plus 3p plus 5. Note that what I did was to factor out p minus 3 and then try to find the other quadratic factor by utilizing what we know about p minus 3 and the given equation. There are alternative ways of doing this. More commonly, we can use synthetic division. If you're more comfortable with doing that, that works too. Just for the purposes of showing it, I'll do it on the side. Let's say we have here 1, 0, negative 4, negative 15 as the coefficients. So 1, 0, negative 4, and negative 15. One of the factors is p minus 3. We'd like to divide it by p minus 3. So our divisor here must be 3. Using the common method, we drop the 1, multiply by 3, add, multiply by 3, get 9, add 5, multiply by 3, positive 15, add 0. Therefore, it's actually p squared plus 3p plus 5 as we have obtained. Anyway, going back, from here we know that p is not equal to 3, so we have to eliminate this condition already. So we're left with p squared plus 3p plus 5 equals 0. We set this aside for now and go back to it later on. Now, we look at the expression we want. That's p times p plus 1 times p plus 2 times p plus 3. If you're given with a product that looks like this, the best recourse is often to pair the factors such that they will end up with uh, common common terms. Like if we multiply p and p plus 3, we get p squared plus 3p. And if we multiply p plus 1 and p plus 2, we get p squared plus 3p plus 2. When I say pair them in a way to get some similar terms, what I mean is to obtain this term here, the p squared plus 3p. So multiplying them the way I did strategically gives us the expression that is common to both of them, that is p squared plus 3p. More importantly, if we go back to what we obtained earlier, that's p squared plus 3p plus 5, we can isolate p squared plus 3p to get p squared plus 3p equals negative 5. And this value here is what we can substitute to the expression we want. So it's if p squared plus 3p equals 5 or negative 5, we get here negative 5 times negative 5 plus 2. Simplify this to get negative 5 times negative 3 or 15. Therefore, the equation that we want is, or the expression that we want is equal to 15. And that's our final answer. Hope you learned something from this video. Thank you for watching and please subscribe for more content.